Bismillah. So in this video, inshallah, I will solve the multiple choices questions for Unit 5. Let's start with question number topic 5.1.1, question number 7. I'll give you a few seconds to read the question. So as you can see, the question is asking about the angular velocity omega of the turntable as function of time. As you know, omega equal the derivative of theta per time. So theta is given in the equation. This is theta. The derivative of this equation is 3 over 2 times 6 multiplied by t 3 over 2 minus 1 minus 2. That's it, right? So after simplifying the formula, we can say that omega equal 9t 1 over 2 multiplied by, minus 2. So the answer is B. I think it's simple question. It's just a derivative after deriving and cancelling, let's say 6 with 2, and the answer here 3. 3 times 3 is 9, etc. Question number 9 for the same topic. Also, please read the question. Again, we need to find the angular velocity. Also, the angular velocity, same way. The angular velocity equal to derivative theta per time. So the answer is 4t minus 5. For time t equal 2 seconds, now we substitute omega equal 4 times 2 minus 5. That means 8 minus 5. The answer is 3 radian per second. So the answer is C. Of course, any other function can be driven the same way. Next, this is a free response, so I will record another video to answer this question, the free response. Now, for topic 3, question number 2. Now, read the question, please. Okay. So, what is the magnitude of the torque due to 5 Newton force? We need to find the magnitude of the torque. We know that tau, the torque, equal R as perpendicular times force. Now, what is R? R is 4, right? Because this is 5, but this is not R perpendicular. R perpendicular is this one. Let's give it another color. The green one, which is 4. So R perpendicular is 4. 4 times 5. Tau equal 4 times 5. So the answer is 20 Newton times meter. So the answer is B. Okay, I'll give you a few seconds to understand the question. Now, next, question 7 in the same topic. Please read it. I'm giving you time to read it. Also in the same way, tau equal RF perpendicular. Now, F perpendicular in this case is the x component of F. And the y component of F. So this is F perpendicular. We can say tau equal R. What is R? R is 5. The y component is 3. And tau equal 15 Newton times meter. Where did this come from? Actually, we know that tau equal R, F sine theta. F sine theta is the y component of F. That's why we used the y component. So the answer is 15 Newton times meter. Question 8. Question 12. I'm sorry. Next question, question 12. Topic 4. Please read it. I'm giving you time to read this one. Question 12. Now, we need to rank the rotational inertias for each situation. Now, actually, if you look at them, first one, system 1, let's write them here. I1, it's M R squared, the original formula. For this one, it's 2m0 times d0 squared plus 2m, the second mass, times d0 squared. So we found it for first mass and second mass. Now, for the let's continue or complete. I1 equal 4m0 d0 squared. Now I2 is, we need also to find the rotational inertia for each mass of those. Now for first one, it's m0 times 2d0 squared, 2d0 squared. And here we need to be careful. The squared is for everything, for 2 and d0, plus same thing for the other mass, 2, not 2, sorry. For the other mass also, it's m0, 2d0, everything squared. I2 equal 2m0, 2d0 squared. That means 2 squared is 4. 4 times 2 is 8. 8 m0 d0 squared. Okay, so this is I2. I3 also, as you can see, there is m0 and 2d, m0 and 2d, so it will be same as I2, same process. So it will be 8 m0 d0 squared. That means I2 equal I3, and both are greater than I1. So the answer is C. Question 17, the same topic. Please read. Also here, they are asking us to find the greatest rotational inertia. If you look at them and try to find it for each one of them, actually for the first one, I equal m0 d0 squared. For the second one, I equal m0 d0 squared. Why we don't consider this mass? Actually, because the distance between this mass and the axis is 0. And if I want to find the rotational inertia for this one, it's equal to m0 times 0 squared. No worries, we can square the 0. So the answer is 0. So I don't care about this mass actually. For the third one, it's I equal m0 over 4 multiplied by 2d0 squared. That means m0 over 4 times 4 d0 squared. 4 will cancel 4. The answer is m0 d0 squared. So which one is the greatest? Actually, all of them have the same rotational inertia. Sorry, let's have this comment here. Always when we have mass or point of mass rotating around an axis, we use I equal mr squared. This is the main formula for this case. Now, let's go to 5.5. 5.5. Read the question, please. First question in 5.5. Okay, so here we need to determine which equation describes the condition of net torque on the board about the appropriate rotation axis. So on the the rotation axis here, the appropriate rotation axis is this one, because the rod will turn around this point since it's the edge of the table. Now, what is the torque? Actually, torque equal to, it's here, we have a space. Torque equal to F times R. Torque equal. What is the force here? Here we need to find 3 torques. Torque for M1, torque for M2, and torque for the board or the rod. For M1, tau equal 1 over 3 M1 GLB. Why? Actually, M1G is the force, and the distance here is 1 over 3 LB. So this is tau 1. Tau 2 equal 1 over. Let's break it down. 2 over 3 times LB. This is the, let's say the distance R. The force is MB times M1 times G. M2 times G, I'm sorry. M2 times G. So this is tau 2. Last one, tau, the board, the torque of the board is. Now, we know that this is the center of mass. of the board, not of the system, of the board only. Now, this distance is R, the distance between center of mass and rotational axis, right? This is the distance. Now, this part is 1 over 3 LB, this part. This part is 2 over 3. No, sorry, this part is 1 over 2, I'm sorry. This part, 1 over 2 LB. This is the middle of the board, right? So, the small distance here, and let's call it RCM. RCM equal LB minus 1 over 3 LB minus 1 over 2 LB. RCM equal 1 over 6 LB. Because, yes, 1 over 6 LB. طيب. Let's substitute it here. Tau B equal F times R. F is MB times G. So 1 over 6 MB times G times LB. So those are 3 torques we have here. Okay. So which formula will give us the right condition? Actually, we need to add them all in one formula, but in one equation, sorry. But also we need to be careful which one is negative and which one is positive, because, for example, the torque of M1 clockwise, the torque of the board itself clockwise. The torque of M1 is counterclockwise. So the only positive one is this one. This one is the positive one because it's counterclockwise. These two are negative because they will be clockwise. So the answer is D. Right? Exactly. Next question. Question number 3. The same topic. Read it, please. Okay. Now, the board is balanced on a pivot. Okay, we need to find the mass of the board. Since the board is balanced, so we can say that net torque equal to 0. Right? So tau, sigma tau equals 0, or tau net equals 0. What are the torques here? We have 2 torques. We have torque because of the mass of the block, and we have another torque because of the board itself. So here we have first force, which is M board times G, and here we have M0 times G. M0 times G. So these 2 forces. Before we start, let's find this distance because we will need it, right? Since this is L over 2, this one is L over 6, so the rest is, now let's call it RCM. RCM equal L minus L over 2 minus L over 6. So RCM equal L over 3. Yes, it will be L over 3. Okay, also that we need to understand that the torque of this force of the mass of the weight of the board is clockwise negative. This one will give us positive torque because it's counterclockwise. So now let's substitute whatever we found here. Two torques, M0 times G times L0 over 8. What is L0 over 8? Actually, this is given. The distance between the pivot point and the mass. It is L over 8. Minus MB, the mass of the board, multiplied by G, multiplied by L0 over 3. This L0 over 3, the distance that we calculated, right? This one is L0 over 3. That's equal to 0 since it's balanced. Now we can divide both sides by G. Since this side is 0, so divide by G will cancel. Divide by L0, divide by L0 will cancel. So the answer is M0 over 8 minus MB over 3 equals 0. Take this one to the other side, or let's add MB over 3, or here add MB over 3, cancel. So M0 over 8 equal MB over 3. MB equal 3 over 8 M0. This is the final answer because they asked for the mass of the board. I hope it's clear. Thank you, and inshallah see you in next video.